So there's a global driver to to address the single-use plastics, particularly in African countries, mainly Kenya, Ivory Coast, Tanzania, and other countries. I think they outlawed the law, the ban of the single-use plastics, and many other Asian countries, particularly in India and Italy, France, they have in place. So they are looking like that to address the plastic pollution issues. The biodegradable plastic will be the main, is the bioplastic. It comes from, you're taking the plant sources material and you're taking the valuable sources like starch, cellulose, lignin. There's a component of any plants. It's not necessarily specific plant. It's any organic biomass. It can be wood biomass, it can be organic waste, any byproducts, any organic biomass can be utilized to develop a bioplastic. So you're extracting the chemicals like lactic acid, chachinic acid, and everything. So you have monomers, and you have to build it up into a long chain. Then you can develop a product. What kind of products you want, like a packaging, and you can design it on the product development. Then you have controlled system after end of life. So still when you design the material, so you can still keeping it. So I want to recycle it. You can design it. And also after end of life, then you can put it in the closed decomposing system. Then the cycle is going back again. So it's a closed, it's a circular economic concept. So that's the approach we want to, the global is going on that. So the drivers of the bioplastic, there's is the main thing is it is addressing the environmental effects, particularly because the raw materials comes from the plant source, is a no hazardous, and is because they're renewable. So it's something like if oil is a non-renewable resources, but the plants is renewable. Every year you can grow the plant and you can take it again. You can this is a kind of renewable. So this called is a sustainable way, and also. So how it's similar like a photosynthesis, taking carbon dioxide and give the oxygen. The same process like your materials going back to the natural cycle, and is you addressing the greenhouse emission. Particularly if you are using the petroleum based and everything, there is emission of greenhouse. So this will, the plant based material, you can decrease the greenhouse emission because derived from the biomass. And also there is opportunity. There is like a end of life option. You can still recycle, and also is the biodegradable. So that is advantage. And also the societal effects. So because it's a new innovation, so many agriculture industry already in stress. There is no value added, and there is no value on this. So this one, it can give a high value. Instead of more than bioenergy, this is we create a high value application like a sugarcane byproducts can utilize. So it can create a bioplastic and material. So it can improve their business as well. So it can contribute to is a kind of new industry can come, bioplastic industry, and also. The chemical industry can green it. Instead of using the toxic chemicals, you can use the bio-based chemicals, so you can green the industry as well. And also because the raw material based from the plant sources, there is a use of healthy and safety is very low, and also the toxicity also to the environment is very low. So there is also societal impact and also the economic. So you can utilize there are abundant of waste in around in even South Africa. You can utilize the agriculture waste like sugarcane byproducts, maize byproduct, pineapple waste, paper industry waste, and wood biomass waste. There is abundantly available. They can utilize to develop that one. So it can contribute to the rural development as well. So it can give a competition. So no need to depend on the oil-based material. So it can give a substitute material as well. So it can because the new kind of like agricultural feedstock using and processing into monomer and other things. There's a new job and a new industry is a possibility to create, and also. So when you go to the industry, there's a new environmental friendly products it can come into the, and also that material you can develop so many. You see, when it comes to the bio-based materials, it's not only going for the bioplastic. It can go for many application. It can go for so many applications like painting and all other aspects, all the sectors. It can be packaging and all the pipe product, everything it can be. So it's not only limited to bioplastic as well. Many sectors can benefit. So, and also it helps saving the waste. So if you look at the global bioplastic production, Asia is leading, then followed by Europe and North America and South America. But if you look at the in Africa, there is no activities. So that is that we need to do something we can develop to address the plastic pollution. But if you look at the market, it was identified, it was the bioplastic technology is a new technology. It was in 2015 is close to 450 billion value, that is taking less than 1% market of the plastics. But if you look at the 2019, it's going to take a 4% market, that is 21 billion. So if you look at it, 2030, it's going to take a 40% plastic market. So there is value of $324 billion. So if you compare with plastic growth production, see every year is 3% annual growth. But in the case of bioplastic, it's close to 32% growth. There is an enormous. So the reason is all the countries going to the green materials, the green products. That is the trend is going. But if you look at the sectors, what are the sectors mainly occupying? Is automotive or packaging? But what we are realizing is the packaging sector. So we found that the packaging sector is the main one is causing the real pollution. So all the countries they're going to bioplastic because they want to address the packaging sectors. So it was found 60% of the bioplastic mainly using for the bioplastics. And another one, this I want to give an overview. To make a bioplastic, like you can use any biomass, like I said, like agriculture feedstock you can use, and lignocellulose forestry resources you can use it, and also organic waste feedstock you can use it. So from that process you can use a biorefinery process, that you are taking the value chemicals, that's called biochemicals. From that you have to compound it and you can make a bioplastics. Then you can design the products. So even another interesting is, once you make, also you can be mechanically recyclable. The bioplastic still is 100% recyclable, but you should not mix with the conventional plastic because the chemical structure is completely different. It's a plant-based, and you should not mix with. So if you 20, even we have done studies, 20 recycling time also, still the same property like a polyethylene and everything. So it gives us the same mechanism, but you have to clearly identify this. You have to proper labeling. There is comes with a plant based and everything. Another advantage is it behaves same, but it can advantages if you have a bio-based biodegradable, but you can go for end of life. There is organic recycling. For example, polyethylene. The similar polyethylene, you can also take it from sugarcane, biopolyethylene. The PET bottle, is the Coca-Cola bottle. Similarly, you can develop, but still the chemical structures are same. So you can recycle biopolyethylene with the existing polyethylene. But in the case of biodegradable plastic, you should not mix with the the chemical structure. So you can recycle BioPET with the same with the conventional BioPET. But biopolyethylene also you can recycle with the chemical base. But the biodegradable plastic, it should be separately recycled. That is a message we want to bring it. So another one, what is the term biobased? So the term biobased comes from the carbon comes from the plant sources. So not necessarily to depend on the fossil fuel, just you can take the same chemicals. That's the message, the bio-based and everything. You can use any sources to develop a bio-based plastic. The value process in the bio-based material, this is a renewable resource coming, so you can make a product. But that the word bio-based, it does not define it to address the plastic pollution. So it's going to be same chemical structure. But if you have a bio-based material, it means it is going to address the plastic. Is no. So you need something biodegradable technology. So that's a difference between bio-based and biodegradable technology. So better clarification, I want to give this one. These are the biodegradable. It can be the left side is a petro-based, the right side you can say bio-based. So similar petro-based, you can develop a polyethylene, polypropylene. Similarly, you can prepare green polyethylene, green polypropylene, green nylon. You can develop, but still is a recalcitrant, non-biodegradable, but recalcitrant. But in the upstairs, there is a like a petro-based biodegradable polymer and also bio-based polymer. This is a classification. So when you do recycling, you should not mix with these together, biodegradable and this one. So if you could properly segregate properly, you can recycle it. So the question always asked, is the bioplastic a solution to the plastic pollution? The answer is no. The reason is, so the carbon comes to the plant, but does not address the plastic pollution issue. If the question asked, is the biodegradability a solution to the plastic end of life of plastics? Answer is yes. If we have a certified, verifiable, biodegradable, compostable plastic is responsible for end of life actionable plastic waste in harmony with circular economic model. So if you want to address the plastic pollution issues, need a biodegradable material. Is not to be bio-based. So I hope you have seen the this news. The Amazon has to pay $1.5 million to settle the California plastic. What they done it? They sold the product. They misused the term biodegradable, and it is distributed in 4 districts in USA. But what they found it, the claim, they didn't specify the claim. What is biodegradable? Is it biodegradable in landfill and compost? Is it certified? No, they just used the biodegradable. So when you use the term biodegradable or compostable, you should be properly certified first before you sell the product. That is the message we need it. So because you can't identify this petro-based is a bio-based, so you need a proper certification. So they had another one. You have seen this one. It's a big, I think UK, one of the Plymouth University, there is stand study. The carrier bag, they put a biodegradable bag, but they put it into the ocean for 3 years. But after 3 years, they taken still holding the weight and everything. It's not degrading. So this means they're misleading the term that properly. So you have to clearly mention which environment you are talking. Is a landfill is biodegradable, is a home compostable or industrial compostable, is a marine. So you got to specifically, that is it's not like you cannot use the term biodegradable. So you have to properly mention where is certified, which environment it can be disposed. That message we need it. Another one, I think Federal Trade Commission, what is happening is, they have a specific additives. They are using called Oxo-additives. They are mixing with the existing polyethylene, like a high density polyethylene, low density polyethylene, polypropylene. They just add 1% into the conventional plastic. They're saying it's a biodegradable. So actually it's not happening. What is happening is that additives, when you mix with polyethylene or whatever, so it has some transition metals, something. So when you expose to the environment, the sunlight and the heat or water is accelerate the degradation. It's fragmenting. Is fragmenting into microplastic, but it's actually not degrading. So what they found it, they claiming is my material is degraded in 5 years time. No, there was no standard. There is a like if you are claiming it's a biodegradable in a compost, you have to properly certify and verify. So another one is they're saying you can use 1% to any plastics. No. So if you are saying that the 1% additives, if you are putting to the low density polyethylene or linear low density polyethylene, each product should be verified. You cannot say you can use any plastic 1%. It has to see 1% if you added, it has to test it and we have to verify it. That set if is for example if you have if is shown you proven the environment claims that is 100% biodegradable, you are applicable only to that product. You cannot tell that no, I can put 1% that it can go to any products. No. So each one it has to be verified. So that is the misleading of the oxo-additive technology. So that is a way more than 200 countries have banned so using the oxo-additives. So another one, this is I want to say this is one of the oxo-additive technology they used to be in the polyethylene bags. But what happened is actually fragmenting. So the additive is accelerating degradation into plastic, but it's not completely biodegradable. So this is they're using cobalt like a heavy metals, cobalt, manganese, iron, zinc. There is so what actually is a radical reactor. So when you expose to the sunlight, it starts to radical reaction. So it can fragment, but actually it's not completely biodegradable. So what will happen? The microplastic, if we put to the landfill, if it will go to the ocean, is still in the microplastic. Then fish can eat. Then again it will come to our food chain. This is the causes. So we need to kind of address that kind of issue. So before go to see when the material go to the landfill or any ocean environment, it's uncontrollable. So before that we have to stop. We have to find out how long it take to degrade. It's scientifically verified and everything. So if you look at there is a certificate. It's in the different European countries, they have a own certificate. Like if you are claiming is my material comes to, they have a logo. So what they're saying is all the countries they're saying my material is biodegradable, they have the similar logo. So it means they can put into the composting condition. So if you want to say my material, you should have a proper, you should not just write biodegradable. You should have a certified logo. It means it's the verified, certified product. It can go for home compost or in industrial compost, in water or soil. So it gives a clarity. So people will understand that is not in South African, particularly in African countries, that we need it. So another challenge is, particularly I'm coming to the industrial processing. They always say, no, bioplastic we have tested is a low properties, is low materials, it cannot replace all the plastic and everything. Yes, the research is still going on to develop improving the mechanical properties, and so trying to find a different application. They're still working on it. And also they say that material, particularly in polylactic acid, as one of the known biodegradable polymer. So it's not suitable for the conventional machine. So you need a special infrastructure. The researchers are still all over the world also trying to address that kind of issue. So if ban is something, plastic ban coming to any countries, like you need to have a the infrastructure should be suitable to already they have machineries. So we want to address they're developing a technology, the bioplastic technology suitable to their machineries, conventional machineries. So that is also we attention. And also they say bioplastic is a low scale production. Yes, because the conversion process is a yield and is very low. So what actually the demand is still when it increases, it can develop. So that is also we address. Another one is cost wise. Because of the new technology, when I started my research in 2007, the PLA it was 15 times expensive. Now the PLA is 3 times expensive. It means the increasing the production, the price is coming down because a lot of countries the policy, everything pressing. So when you have a proper standard policy, everything, the plastic also can be cheaper similar to conventional plastic prices. And so the contamination, if you're not properly segregated, if you mix with the biodegradable plastic with the conventional plastic, it will contaminate. Yes, true, because the chemical structures are different. But if you segregate properly, proper labeling, and you can recycle same. And also this, I feel that also give an opportunity, new recycling stream. Like how you have a high density polymer, you have a two, and PET partly you have a recycling. Similarly, you can put a one recycling number, so the people will identify it comes from the plant sources. It should be it has to go to separate recycling stream. So still it can be addressed.